Now, what we've just taken a look at can also be used for doing color corrections on images. Let's say you're working at a studio and somebody comes in with a photograph that's been sitting on their grandparents' piano for the last 30 years in the sunlight. You ever seen one of those photographs that's really kind of faded out and you're losing a lot of the color in it? See how we can fix the color in one of those. Go into the folder called Lab 10, and there's a picture of a castle in there, Neuschwanstein. And you'll notice that its color is, well, shall we say, off. Do you think we can fix the color of this image? No. I think we can. Everything we need is in there. Remember, every photograph that we're working with in Photoshop is a combination of 3 individual color channels. And let's take a look at these color channels here. Red, green, and blue. Okay. The red channel, well, looks like it's got some issues going on there. The green channel actually looks pretty good. We've got some nice deep shadow information in there. We've got some nice bright highlight information. Okay. The blue channel, not so good. And when pictures fade, certain colors tend to fade more than others. Have you ever seen a Coke can that's been lying in a field for like a few months and you kick it and one side is yellow and the other side is red? Because those red dyes fade fairly quickly and you're left with whatever was left. And that same thing happens to photographs. So you might find that some channels are pretty good, some channels aren't looking so good. But let's see if we can fix this image in a very technical sort of way. Imagine this. If we could find the absolute darkest pixel in this image, and it was, say it was a good image to start with, on that histogram, we could assume that the darkest pixel would be black. And what are the RGB values for black? 0, 0. 0, 0, 0. Red would be 0, green would be 0, blue would be 0. Everything's 0 for black. The highlights, we could safely assume, would be white. And what are the RGB values for white? 255, 255, 255. Okay, what if we could find the darkest pixel in this image and tell it to become black? And find the brightest pixel in the image and tell it to become white? Let's see if we can do that. There's an adjustment layer that sets a point and says anything darker than this point will become black. Anything lighter than this point will become white. And that adjustment layer is called threshold. In your layers panel, throw on a threshold adjustment layer. And you'll notice that the image will suddenly become crazy high contrast. Look at what's happened. Here's our threshold. We've told it anything darker than 50% gray, anything darker than 128, which is what we call 50% gray. Here's 0, here's 255, there's your 50% gray. Grab that threshold and move it around a bit. Pull it left, pull it right. See if you can figure out where the darkest pixel in this image is hanging out. I start hefting this, say, to the left here.
How do I get to the threshold?
In the layers panel, at the bottom, you'll see a bunch of little icons. Right between this little rectangle and the folder icon, there's this little circle, half gray, half white circle. If you click on that, you'll see a pop-up of all the adjustment layers. And we're using the threshold adjustment layer. And we're going to try to find the darkest pixel in this image. And it's looking like it'll be somewhere down in these trees over here. And look at this. As I pull this further down, more and more of these pixels turn white. The last pixels to disappear will be, the darkest pixels. And for me, it's looking like 97. I still see some pixels. Zoom in. Do a Command++. If you want to pan around the image, if you hold the Spacebar, you'll get your hand tool, and you can pan around the image. Look at this little clump in here. This looks to be some really dark pixels. How could I identify these pixels for future reference? Because if I turn this adjustment layer off, I don't see those anymore. Here's something cool. Hit I on the keyboard, like the letter I. Don't hit your eye on the keyboard, that could hurt. But just hit the letter I, and that'll take you to your eyedropper tool. And if you click and hold on the eyedropper, you'll see something called a color sampler tool. Use that sampler tool and click on one of those black pixels. And then zoom back out. We have identified the darkest pixel in that image. Now, let's see if we can find the brightest pixel in the image. So grab that little threshold slider again. And if you've lost your pop-up, just go to the icon for that threshold adjustment layer and just do a double click on it. See this little icon here? Just do a click, click. Grab that slider and pull it to the right. And it's looking like our brightest pixel is going to be somewhere over on the left side of this tower here. Let me pull that up a little further. Oh. So for me, the last pixels to disappear are around here. And if I zoom in on it, yeah, I can see that tower there. And I'm going to drop a sampler on, I'll stick it on this pixel here. Boink. It doesn't really matter which of these white pixels, they all have basically the same value. And if you zoom back out, look at that, I have 2 color samplers on there. One representing the darkest parts of the image, and one representing the brightest. So once you have found your brightest and darkest pixels, we got what we needed from that threshold adjustment layer. Throw it in the trash. I know it sounds cold, it sounds callous, but we've done with it. So just grab that little threshold adjustment layer and drag it into the trash icon at the bottom of the layers panel. You'll notice the color samplers remain where they are. Now, we need to tell Photoshop to make this pixel black and to make this pixel white. And here's how we're going to do that. Go back to your adjustment layers pop-up and grab a curves adjustment layer. And you'll see some icons down the left side here. We've got a black point eyedropper, a white point eyedropper, a mid-gray eyedropper. If we grab the black point eyedropper and then pan down to wherever that first color sampler is and click on it. Boink. We've reassigned that pixel to black. Now, the highlights still have a little bit of a color issue. So if we take the white point eyedropper and click on our brightest pixel, the highlights get cleaned up. There's before, and there's after. OK, so let's talk about what happened there, because the image was way off color, wasn't it? So we told Photoshop to do something to the RGB values. So let's take a look at the RGB values before we started. If I turn off the eyeball on that curves, you can see where the image started, way off color. And look at this. If I go into my info panel here, color sampler number 1, which is this guy here, and there's his RGB values. He was 240, 1, 22. And if you look in the channels here, well, there's the red channel. Oh, look at that. The red channel was almost white in those shadows. And we know that it was 240. From 0 being black, 255 being white, it was really bright, which obviously isn't going to look very shadowy. Blue channel was also really bright. Blue was 222, but green was 1. Green actually had pretty good shadow information, which is why we had this very strong magenta cast. The opposite of green is magenta. So there was not a lot of green information in the shadows. We saw the opposite of magenta. By clicking with the black point eyedropper, if I turn this layer back on, there we go. If you go to info, we get 0, 0, 0. So where we had a really bright magenta color because there was not a lot of green and there's a lot of red and a lot of blue, now we have black. And same thing for the highlights. Where we used to have, in this part over here, you can see it has a bit of a magenta purplish sort of look. And if you look at the info for it, it was 255, 201, so it was deficient in green. The opposite of green is magenta. Now it's 250, 251, 251. So it's basically become white. In this case, we were able to use the darkest and brightest pixels to balance out the image. Now let's get you guys playing around with that. In the next folder, you will see some images which are damaged. Pick any 5 and restore their color. So same sort of deal, find the brightest pixel and the darkest pixel. And actually, guys, take a look at the screen for a second. Here's kind of a visual way of doing this. Take a look at the image here, and if I throw on, let's say do like a levels or a curves adjustment layer, if I go into just the red channel, notice how this becomes kind of obvious. I can see this big flat spot here. Instead of having to find the exact brightest pixel, sometimes going through channel by channel, not just RGB, but the red channel, close up that flat spot, the green channel, close up that flat spot, and the blue channel, close up that flat spot. can go a long ways to fixing the color of the image. Now, sometimes making the blacks black and the whites white isn't enough. Notice in this case, he still has a bit of a color cast to it. What color do you guys see in there? He's looking kind of greenish a bit, isn't he? If I go to the green channel, grab this middle slider, I can pull some of the green out of that image. Same thing with this image here. If I went in and I went and found the absolute darkest pixel and used all of those, wait a minute, none of these channels have any flat spots on the end. So there's no endpoints that can be pulled in, or finding the brightest and darkest pixels wouldn't necessarily help us. In this case, we just have to figure out what sort of color cast he has. Now this is interesting. What sort of color cast do you think this guy has? Red, here's the thing. Some colors are really tricky to figure out which is which. And it does kind of look a bit reddish in here. But in photography, we're working in RGB, red, green, and blue. And the red, green, and blue colors each have opposites. The opposite of green is magenta. The opposite of red is cyan, and the opposite of blue is yellow. In this case, it's not actually a red cast. And one way to figure that out, if I go into the red channel and I start subtracting red, it doesn't fix the color. I still see what now appears to be a bit of a purplish color in there. So in that case, I know that it wasn't red, so I'll put that back to 1.0. In the green channel, though, if I start adding green, which subtracts magenta, that cleans up the image. So if you can't quite nail down what the color problem is, sometimes go through the channels and use the middle slider. Here's adding some magenta or subtracting green. Here's adding green or subtracting magenta. And that seems to clean up the image.